Hello everyone watching this video. I have made this video for Tathva 2021, a technical symposium conducted by National Institute of Technology, Calicut for the event Famous Challenge. My name is Sriniket. I am from PSC Institute of Technology and Applied Research, Coimbatore. I am from EC department, a freshman as well. So without much delay, let me just go on to the topic which I'm going to derive. It's nothing but the Schrodinger's wave equation. The reason I chose this topic is my friends, my peers felt that while teaching, while my tutors were teaching, they felt this topic to be difficult because of the derivation or the number of steps involved. So I felt that I would take this as a challenge to teach them, as well as to everyone who faces the problem in Schrodinger's wave equation, so that they could easily find a solution to it. So that's the thing I've chosen this topic. And the formula for Schrodinger's wave equation is minus h cross square by 2m into delta square plus v into psi equals I into h cross into dou psi by dou t. So it may be difficult to spell it out for myself as well. But when we derive it, it's going to be very, very simple. So I'm not going to make it too complicated as well. So now, this is Erwin Schrodinger. He is an Australian-Irish physicist, and he is also considered as the father of quantum mechanics. So, without much delay, let me move on to what is Schrodinger's wave equation. So, Schrodinger's wave equation, one of the basic equation in quantum mechanics. It can be used for macroscopic and microscopic particles. This equation describes the motion of atomic particles like electrons in an atom or a metal. Actually, there are two forms of Schrodinger's wave equation. One is the time-dependent and the time-independent wave equation. So now I'm going to derive the time-dependent wave equation because that these are like two different things. Like time-dependent and time-dependent independent variation equations are two different things. So for one video, I think time-dependent equation is very much sufficient to derive. So for which I have considered this part, that is nothing but psi of xt, which is equal to a e power I into kx minus omega t. So where psi of xt is nothing but the wave function, and this is nothing but equation in a polar form. So to convert this into a Cartesian format, we have to use this small mathematical thing, that is nothing but e power I theta equals cos theta plus I sin theta. So where theta is nothing but cos of kx minus omega t, and we get this derived this equation. So this is the initial equation for the entire derivation. So just keep it in mind. And then to make this derivation very simple, I have used to derive the splitted the entire derivation into three steps so that we could ultimately arrive at this part, that is nothing but the Schrodinger's wave equation, at which the first step is nothing but the second order differentiation of psi, and the second step is nothing but finding the total energy, and ultimately we just do few changes to it, we'll arrive at this step, that's the final Schrodinger's time dependent equation. So without much delay, let me move on to this derivation part. So first is nothing but the second order differentiation of psi. So we know that from the previous equation, I told that this is the initial equation for the entire derivation. So I've just considered it, and I've made there are differentiated ones with respect to x. So differentiation of cos is sine minus sine, and differentiation of this part, that is the theta part, will give us k. So differentiation of sine is cos, and differentiation of this part will give us k again. So we know that k is common in both the terms. So we could take k commonly out and write the remaining part as x. So now again differentiating with respect to x. So differentiation of sine is cos x, and we know that if we differentiate this part again, we get k, and differentiation of cos is minus sine, and differentiating this part, we'll get k again. And since k again is common in both these terms, as in the first order differentiation, I take the k common out and we get k square. And if you see this part of the term, it's nothing but the initial equation which we consider. So I replace that as psi of xt. So ultimately we get the second order differentiation is nothing but minus k square into psi of xt. Now let's move on to the second step, that is nothing but deriving the kinetic energy term, that is the ke term, and then substituting it in this equation. So for that, I just multiply it with Ke. So Ke on both sides. So I get this one. So find Ke, I move on to the small derivation. So we know the kinetic energy Ke is nothing but half mv square. So I multiply and divide by m on both sides. So I get m square v square by 2m, which is nothing but p square by 2m. And according to de Broglie's hypothesis, we know that lambda equals h by p. And we also know that for wave number is nothing but k equals 2 pi by lambda. So from this lambda, I just transform this equation like this. So lambda equals, lambda equals 2 pi by k. So from this lambda and this lambda are same. So I just equate both and, and write this equation in terms of p. So we get hk by 2 pi, where hk by 2 pi is nothing but h bar or h cross. So it is nothing but the reduced Planck's constant, and its value is 1.038 into 10 power minus 34 joules per second. So substituting this value of P over here, we get kinetic energy equals h cross square k square by 2m. So I just substitute this value of kinetic energy over here, and this is nothing but this term. So we get h cross square k square by 2m instead of kinetic energy, and writing the remaining term as it. And this is the second part of deriving the kinetic energy term and substituting. So step 2 is over from this equation. So now moving on to the step 3 or the final step so that we could easily derive it. So this is the one which we had derived previously. So that's remember in mind. So on the total energy E is nothing but kinetic energy plus potential energy. So I multiply with the term psi of xt, that is nothing but the wave function on both sides. So if we see this term, which is nothing but this term which we had derived previously, and I substitute this value over here. So I get this one, this term over here, and the entire equation is now changed to this one. Now, which I just reorder this equation so that I will get the final equation for the Schrodinger wave equation, which is nothing but this one, that is minus h cross square by 2m into dou square by dou x square plus v of x into dou psi of x comma t, which is equal to e into dou psi of x comma t. If you want, we could replace dou square by dou x square as delta square, which is nothing but Laplacian operator. Since we have got only considered for a single dimension, we could use x square. If it's for 3 dimensions, we have to consider x, y, and z term as well. And so ultimately, we have derived our final equation successfully without much hassle. So let me just brief about our equation once again so that it will be completed. So which is nothing but minus h cross square by 2m into delta square, which is equal plus, which delta square is nothing but the Laplacian operator I told earlier. So this is nothing but Laplacian operator for 3 dimensions. So which is delta square plus b into psi. Psi is nothing but the wave function, which is equal to e into psi of x comma t. But we know that e is nothing but I into h cross into dou by dou t. So I just replace e as I into h cross into dou by dou t, and we have psi term as well, so which gets filtered over here. And we know that delta is an Laplacian operator, psi is the wave function, v is the potential, and h cross, which is h by 2 pi, is nothing but Planck's constant, having a value 1.038 into 10 power minus 34 joules per second. So ultimately, we have derived this equation, which I think my peers as well as everyone who feels Schrodinger time-dependent equation to be difficult are able to understand it. So thank you. Thanks for the patience here, patiently hearing the video. And this is actually the fourth or fifth trial I'm doing this video. Hope that my efforts get paid off. Thank you. Thanks a lot.